start with a short introduction about statistics. Statistics is a mathematical science including methods of collecting, organizing and analyzing data. We have to collect the data and then organize it and then analyze the data in such a way that meaningful conclusions can be drawn from them. In general, its investigation and analysis fall into two categories, which are descriptive and inferential statistics. Our first unit is measure of central tendency. Measures of central tendency are also usually called as averages. They give us an idea about the concentration of the values in the central part of the distribution. Here 5 measures of central tendency are given below. First one, arithmetic mean, median, mode, geometric mean and harmonic mean. In this presentation, we are going to see what is arithmetic mean, median and mode. Arithmetic mean is the most used measure of averages, so it is also called as average. We know what is average and how to calculate average. In this, arithmetic mean is having 3 datas. Number 1 is raw data and then discrete data. Last one is continuous data. In raw data, we have individual observation. If x1, x2, x3, etc. up to xn are n observation of the series, then the arithmetic mean is denoted by x bar and it is given by x bar is equal to summation x divided by n. Here summation x represents x1 plus x2 plus etc. up to xn. For discrete data, our formula is x bar is equal to summation fx divided by summation f. Here f is our frequency. This formula is also can be written as summation fx divided by caps n. Here caps n is equal to summation f, which is total frequency. For continuous data, x bar is equal to a plus summation fd divided by n into c, where a is assumed mean, d is equal to x minus a by c, n is total frequency or summation f, c is class limit. In continuous data, the above formula is step division method formula. We have one more method, which is direct method. In this method, we are using discrete data formula, which is x bar is equal to summation fx divided by summation f. Let us see one example. The marks obtained by 10 students in a class are, the data are given below. Calculate the arithmetic mean. In this question, we have individual observation. So we have to use raw data formula, which is x bar is equal to summation x divided by n. The given datas are our x values. So we have to find the sum of x, which is we have to add all the datas. So we will get 570 divided by n is the total number of students is 10 students obtained the marks. So 10 is our n value. So n is equal to 10. So 570 divided by 10, which is 57. So our arithmetic mean is 57. Find the arithmetic mean for the given data. Here wages and frequency are given below. So in our question, they are given some frequency data. So we have to use our discrete data formula, which is x bar is equal to summation fx divided by summation f. In our question, they are given wages, so we have to take wages as x and frequency as f. So let us construct an table. We have to put our x value and f value and then we have to find fx, because in our formula, we need summation fx divided by summation f. So summation f is nothing. We have to add all the frequencies. So you will get summation f, which is equal to 300. Summation fx is, we have to find first fx, which is f into x value. So 8 into 125 is 1000. 24 into 135 is 3240. 52 into 145 is 7540. Similarly, we have to find all the values in f into x. So after finding summation fx, we have to sum all the datas. We have to add all the datas in fx. So you will get summation fx is equal to 48,300. So now substitute into our formula, x bar is equal to summation fx divided by summation f, which is 48,300 divided by 300 is equal to 161. So our arithmetic mean is 161. Our next example is for continuous data. Calculate mean of the following data. The data are given below. marks, number of students. In marks, we have data like intervals 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. If it is our question is like intervals, you have to use our continuous data formula. X bar is equal to A plus summation FD divided by N into C. Let us construct an table. Our first column is class interval, which is our marks, and second column is frequency, which is number of students given in our question. Our third column is mid value of X. Mid value, how to find mid value X? Which is we have to find average of class interval 0 to 10. So 0 plus 10 divided by 2, which is 10 divided by 2 is equal to 5. Similarly 10 to 20, 10 plus 20 divided by 2, 15. 20 plus 30 divided by 2, 20 plus 30 is 50, 50 divided by 2 is 25. Like that you have to find the average of the class interval, which is our mid value of X. After finding mid value X, you have to assume a mean value, which is you have to point out some center value in your mid value X. Here 25 is your centered value, so we are taking assumed mean as 25. After finding our X and A, you have to substitute into our D formula. D is equal to X minus A by C. Here we know what is X, what is A, and we have to find what is C. So C is class limit. Here we have common difference in all the class interval is 10. Because 0 to 10, the in between common difference is 10. And 10 to 20, which is also common, the common difference is 10. Similarly, for all the class interval, our common difference is 10. So C is equal to class limit is equal to the common difference of all the class interval, which is equal to 10. So D is equal to X minus A divided by C. Here X in first column is 5 minus A, assumed mean is constant 25. So 5 minus 25 is minus 20 divided by class limit is 10. So minus 20 divided by 10 is equal to minus 2. Similarly, our second value X is 15. 15 minus assumed mean is 25. So 15 minus 25 is minus 10 divided by our class limit is also 10. So minus 10 divided by 10 is equal to minus 1. Similarly, our next mid value X is 25. Our assumed mean is also 25. So 25 minus 25 is 0. So 0 divided by anything will be obviously 0. And then our fourth mid value is X is 35. So 35 minus our assumed mean is 25. So 35 minus 25 is 10. 10 divided by our class limit is 10. So 10 by 10 is equal to 1. And the last mid value is 45. So 45 minus assumed value, assumed mean A is 25. So 45 minus 25 is equal to 20. 20 divided by our class limit 10. So 20 divided by 10 is equal to 2. So these are our D values. After finding D, you have to multiply F into D. So 7 into minus 2 will be minus 14. 12 into minus 1 will be minus 12. 24 into 0 is equal to 0. 10 into 1 is 10. 7 into 2 is 14. So which is our FD. If now we have to sum all the values in FD, which is we have to add all the values in FD. So you will get summation FD is equal to minus 2 and summation of F is or summation or N caps N is equal to 60. So now we have summation FD value and caps N value. So we have to substitute into our formula. X bar is equal to A or caps A, assumed mean is 25 plus our summation FD is minus 2 divided by caps N is 60 into C, our class limit is 10. So if we solve these terms, you will get 24.667, which is your arithmetic mean for continuous data. In continuous data, we can use a direct method formula, which is X bar is equal to summation Fx divided by summation F. Here we are using discrete data formula. So if you use the discrete data formula, we will get the same solution. So you can use for step division method or direct method. Next definition is median. If the observations are arranged in ascending or descending order, then the middlemost item is called median. Here also we have three data. First one, raw data. In this data we are having two cases. First one is odd case and then even case. If n is odd, then our median formula is n plus 1 by 2th item. If n is even, then our median formula caps m is equal to n by 2th item plus n by 2 plus 1th item, the whole thing divided by 2. In discrete data, here also we have two cases. If caps n, which is summation f, total frequency is odd, then our median caps m is equal to n plus 1 by 2th item. If n is even, then caps m is equal to n by 2th item plus n by 2 plus 1th item divided by 2. For continuous data, our median formula is L plus n by 2 minus m divided by f into c, where L is lower limit of the median class, caps n is total frequency, which is summation f is frequency of the median class, small m is cumulative frequency of pre-median class, and c is class limit. Let us see one example. Find the median of the data are given. We have to arrange first the data in ascending or descending order. Then we have to count how many data are there. Here 7 data are given. So n is equal to 7. So 7 is obviously odd. So we have to use the formula n plus 1 by 2th item. Here n is 7. So 7 plus 1 by 2, which is 8 by 2th item, which is 4th item. So our 4th item is 7. So our m median is equal to 7. Our next example is find the median for the data. So first we have to arrange in ascending or descending order and then count how many data are given. So here 6 data are given. So small n is equal to 6, which is even. Our median formula for even is m is equal to n by 2th item plus n by 2 plus 1th item divided by 2. So our n by 2, n is 6 by 2 plus 6 by 2 plus 1th item. 6 by 2 is 3 and 6 by 2 plus 1 is 4. So our third and fourth items are 40 and 52. So 40 plus 52 divided by 2 is 46. So our median is 46. Next example is for discrete data. Calculate the median. The wages and number of workers are given below. We have to take x as wages and f as number of workers frequency. Our CF is cumulative frequency. We have to find CF by using our frequency values. In our frequency, our first term is 8. So in our cumulative frequency also, our first term is 8. In our frequency, our second value is 10. So we have to add 10 plus first value in frequency. 10 plus 8 is equal to 18, which is your second cumulative frequency. Like that, you have to add third term, second term plus first term. So 11 plus 10 plus 8. So you will get 29, which is your third term of cumulative frequency. Similarly, you have to add 16 plus 11 plus 10 plus 8, which is 45. So which is your fourth term of your cumulative frequency. Like that, you have to add all the terms together. So you will get a cumulative frequency one by one. So you can check your cumulative frequency is correct or wrong by using your total frequency, which is summation f is equal to 120. So you have to check your last term in cumulative frequency is also 120. If it is same, so your cumulative frequency is right. So you can proceed the further steps. Here n is equal to 120. So which is even. So we have to use our median formula is caps n by 2 item plus caps n by 2 plus 1th item. Here 120 divided by 2 is 60th item plus 120 divided by 2 plus 1 is 61st item. So here what is 60th and 61st item? So you have to check in cumulative frequency which term exceeds, which is more than 60 and 61, which is your 60th item and 61st item. So in cumulative frequency we have 65, which exceeds 60 and 61. So 65, the corresponding x value is 24. So we have to take a 60th item is 24 and 61st item is also 24 because 60 and 61 both are exceed 65. So we are taking 24 as our 60th and 61st item. So 24 plus 24 divided by 2, which is 48 divided by 2. So yeah, median is equal to 24. Next example is for continuous data. Find the median for the following data. Here class interval and frequencies are given below. we have to construct a table. First one, class interval, and then frequency, and then cumulative frequency. I already told you how to find cumulative frequency. Here our frequency first value is 29. So our cumulative frequency first value is also 29. And then frequency second value is 195. So we have to add second value plus first value. So 195 plus 29, which is 224, which is your second cumulative frequency, 224. Like that you have to add third value plus second value plus first value. 241 plus 195 plus 29, which is equal to 465, which is your third value of cumulative frequency. Similarly, you have to add first four values in frequency, you will get 582, and then first 5 values in frequency, you will get 634, and first 6 values in frequency, you will get 644, which is like that. If you add all the terms together, you will get cumulative frequency. So after finding cumulative frequency, you have to find summation F, which is your total frequency, which is 655. So you can check your cumulative frequency loss value with your summation of total frequency value. If it is same, you can move on further steps, which is you have to use your median class formula for continuous data. M is equal to L plus N by 2 minus M by F into C. Here N is 655 divided by 2 is equal to 327.5. So here 327.5 is your N by 2 value. So you have to check this value into your cumulative frequency, which exceeds 327.5. So more than 327.5 is here 465, because the upper value of 465 is 224, which is least value of 327. So we have to take 465 as 327.5 is exceeds value. So in this 465, you have to take the corresponding class interval and frequency. So here corresponding class interval is 10 to 15 and the frequency is 241. So our lower limit of class interval is 10, because 10 to 15, so lower limit is 10 and frequency is 241. Our median class is, our cumulative frequency is 465. So we have to take our cumulative frequencies pre-median class before term, so which is 224. So you have to take your small m as 224 pre-median class in cumulative frequency, so which is 224. And then C is, I already told you, C is class limit, which is common difference of all the class interval. So here 0 to 5, 5 to 10, so common difference is 5. So our class limit is equal to 5. So we have to substitute all these terms into a formula. So m is equal to 10 plus, because our L is 10, so 10 plus N by 2 is 327.5 minus pre-median class is 224 divided by F is 241 into C is F 5. So if we solve this term, you will get M is equal to 12.1473, which is your median value. Thank you for watching this video.